Okay, this is homework number 2. It's due Friday. And let's start with problem 1-40. A line passes through the points -3, -2, and 2, 1. Does it also pass through the point 5, 3? Well, let's actually graph the points. I'm going to use Desmos, which is kind of like an online graphing calculator. So let's see. The points that were given were -3, -2. Let's label that. And then we also had 2, 1. Let's label that. So this is our graph. And then that's A and that's B. Now we have a C over here at 5, 3. So let's put that on there too. 5, 3. Now the question is, if we draw a line through these 2 points, will it also hit that point? So let's see. So let's put this on the document. Alright, so there's my graph, right? And I'm going to draw a line from A to B. And when I drew this line, if you count along the grid, from A to B, you actually go up 1, 2, 3 boxes, and then you go to the right 1, 2, 3, 4, 5 boxes. And that's important. So the question is, if this pattern continues, we would have to go up 1, 2, 3 boxes, and then we'd have to go to the right 5 boxes, right? So if the pattern from A to B continues, we'd have to go up 3 boxes, and then 1, 2, 3, 4, 5 boxes to the right. So you notice that from B to C, it's actually only up 2. Let's see, from B to C, if I drew a little line there, it's actually only up 2 boxes and right 3. So that's not the same pattern, right? That's not the same pattern. So what do we say here? Oops. We say that doesn't pass through C. And the reason is, there's answers may vary here, so I'll write that. Answers may vary. So I can say that the line instead of it. The line follows a different pattern. Maybe it would be better to say a different growth pattern from A to B versus B to C, right? So we wouldn't be able to draw a straight line through all 3 points. That follows a different growth pattern from A to B than it does from B to C. And that's why the answer is no. Okay, so since I did all of the last one, I'm just going to do 1 on these. And the one I'm going to do is C. Is it a function? And then, if it's not a function, give a reason to support your conclusion. So, let's check. For this function, we have an input of 7 with an output of 10, right? And then we have an input of -2, output of 0, no problem. But if you notice, there's another input of 7 with a different output. So this is actually a problem. C is not a function. And it is not a function because the input x equals 7 has 2 different outputs. If it's a function, every input can only have 1 output. So because 7 has an output of 10, and then 7 also has an output of 3, it's not a function. So it has 2 different outputs. And those 2 different outputs were 10 and 3. If you actually graphed these 2 points, right, 7, 10, that's 7, 10, and then 7, 3, here's 7, 3. If you actually graph those 2 points, it would not pass the vertical line test, right? Because if you do a vertical line, it would hit both of those points. So that's a graphical way to understand this is, if you graphed this table as points, these 2 points would cause it to fail the vertical line test. 1-48. Find the x and y intercepts for the graphs of the relationships in problem 147. Okay, so what we need to do is A and D only. Alright, and I'll do D, and I'll leave you to finish with A. So for D, we're looking for x intercepts, and we're looking for y intercepts. Let's see. So if I'm looking at the x-axis, the graph hits the x-axis in 2 places. That's 1, 0. And then right here is -1, 0. So there's actually 2 x-intercepts. And we normally write these as coordinates, right? Because the coordinates of that point and that point are 1, 0 and -1, 0. Alright, then we look for the y-intercepts. Where does it hit the y-axis? So this curve hits the y-axis right there. And the coordinates of that point are 0, 0, -1. That's -1. So it just has one y-intercept. Don't forget to do A. 1-49. For the following tile pattern, find the growth rate of the pattern, which is the number of tiles added to each figure. The number of tiles in figure 8, sketch figure 1 below. Alright, so if we look at figure 2, 7 tiles. Figure 3, 9 tiles. And figure 4, 11 tiles. So if you notice, the 2 tiles on the right are new to each figure. Those are the 2 tiles that are getting added. So you can write the growth rate as 2 tiles are added to each figure. Alright, and if this pattern continued, we'd have figure 5, figure 6, figure 7, and figure 8. So we have 7, 9, 11 in figure 4. That means we're going to have 13 in figure 5, right? It grows by 2. Add 2, 15, add 2, 17, add 2, 19 tiles in figure 8. Okay, and that's because, again, we're adding 2 to each figure, so if you just keep adding 2 until you get to figure 8, you'll have 19 tiles. Don't forget to do C. Here's 1-50. Solve each equation, check the solution. Alright, so I'll do A and C. Starting with A, we want to combine like terms. So we can see that 10 on the right hand side is fine, but on the left hand side, we have a 6 and a -3. And 6 minus 3 is 3. 3, and then we have a subtract x. 3 minus x. Alright, now I'm going to isolate x. I'm going to take away 3 on each side. 3 minus 3 is 0. 10 minus 3 is 7. And be careful, this is still minus x, or negative x. So we have negative x equals 7. So the last step is divide both sides by -1. Negative divided by negative makes positive. So we have x equals, x divided by 1 is x. And then on the right hand side, 7 divided by 1 is 7. And a positive divided by a negative stays negative. So x equals -7. Now if we check our solution, we have 6 minus, plug in -7 for x. So 6 minus -7, and then subtract 3, that should equal 10. So when you subtract a -7, 6 minus -7, it becomes a plus. So it becomes 6 plus 7, and then take away 3. 6 plus 7 is 13. Oops, this should be equaling 10, 10. So 6 plus 7 is 13, and then if you take away 3, that's 10. So it is correct. Both sides match. Alright, let's try this one. This is tricky. So, when you have an equation with a fraction, the best thing to do is look at the denominator, which is 3. Alright? And then what you do is multiply both sides by 3. Okay, so we distribute the 3 to both sides. 3 times a third, that's going to be 3 over 3x plus 3 times 4 is 12 equals, alright, 3 times x, distribute the 3, is going to be 3x minus 3 times 2 is 6. Okay, so this equation is much nicer to work with. When I distributed 3 times a third, I kind of skipped my work there. I just multiplied 3 times the numerator, 3 times 1, which is 3. Now the beauty of that is 3 divided by 3 is just 1. So we have 1x plus 12 equals 3x minus 6. Since we have an x on both sides, I need to choose the smaller x and make it cancel. So subtract 1x from each side. We get 12 equals 2x minus 6. Alright, and then we need to isolate x, make x alone, so add 6 to each side. So we get 2x equals 18, and then divide both sides by 2. X equals 18 divided by 2, x equals 9. Check solution. Alright, so when you're checking your work, you write out the equation, and then you substitute x for the solution, 9. So let's take 1/3 times 9 plus 4 equals 9 minus 2. Alright, now 9 times a third, you just multiply the numerator, 9 times 1. Alright, so that's going to be 9 over 3 plus 4 should equal 9 minus 2. 9 minus 2 is just 7. Now 9 divided by 3 is 3. 3 plus 4 equals 7. 7 equals 7. Check. Don't forget to check your work. 159. Is this a function? What's the domain? What's the range? Alright, so to check if it's a function, you check to see if it passes the vertical line test. Every vertical line only hits once. Oops. Erase those so you can say that yes, it is a function. Each input has only one output. Okay, the domain. So the domain, remember, is left to right, and the range is bottom to top. So let's check. On the left-hand side, the furthest left we can go, and domain refers to the x values, range refers to the y values. So the number on the x-axis is -6, so it's -6, and then the furthest right x value is right here, and the value for x there is +6. So -6 to 6. Now to write that with inequality notation, we say that x, right, x is less than or equal to 6. And remember, start with a variable. X is greater than or equal to -6. So the signs look funny here, but x, remember, start with a variable. X is greater than or equal to -6. Alright. And then for the range, if we need to identify the lowest y value, the range is the y value, the lowest it goes, the y value right there is -4. Alright, so we have -4, And the highest this graph goes is right here. So what's the y value right there? That's 4. So it's negative 4 to 4. Now you need to write it with the inequality notation. Because it's ranged, don't forget about y. I'll let you finish that one off. 1-60, the cube root of 27. Cube root means what number multiplied by itself is going to be equal to 27? 3. 3 times 3 is 9. And then 9 times 3 is 27. Let's check. So what number was it? It was 3. 3 multiplied by itself 3 times. That's what this little thing tells you. That's cube root. It's 27. So that's our answer. Okay, you can do B, and then C, we have the square root of 3 squared. So don't forget about exponent. Exponent always comes first. 3 squared is 9. 3 squared is 3 times 3, which is 9. So that's just the square root of 9. And the square root of 9 is 3, right? Because 3 times 3 equals 9. So the answer is there. 1-61. Calculate f of 4 for each function below. When the number is given in the parentheses, that's x. That's the input. Alright, so let's try B. F of 4 equals 1 over 5 in parentheses raised to the power of 4. So when you have something raised to the power of 4, that tells you you need to repeat it 4 times. Oops, and I'm sorry, we're repeating 1 over 5. And these are all multiplying, so we just multiply across the top. 1 times 1 times 1 times 1, and then across the bottom, 5 times 5 times 5 times 5. Alright, now 1 times 1 times 1 times 1, that's just 1. But what is this 5 thing? So let's get out the calculator. And let's check. 5 times 5 times 5 times 5 is 625. Alright, and if you want to write it with your function notation, it's f of 4 equals 1 over 625. Let's try D. I'll do it in a different color. D, we're still calculating f of 4, so we replace the input x with 4, and it's going to be 4 minus 2 cubed minus 6. Go inside the parentheses first. So it's 4 minus 2, whatever that is, it's going to be cubed, right? So it's just 2 raised to the power of 3. Now 2 raised to the power of 3, that's 2 times 2 times 2, 3 times. And 2 times 2 times 2 is 8. 8 minus 6 is 2. The answer is 2, and then with function notation, that's going to be f of 4 equals 2. Alright, use what you have learned about exponents to rewrite each of the following expressions below. Alright, A, h11 over h9. I'm going to do this first one by expanding. h11 means there's 11 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, and then on the bottom we have 9 h's. 5, 6, 7, 8, 9. Now h divided by h is 1, so these all turn into giant ones. So what's left is 1 times h squared, right? Because h times h is h to the power 2. Or just h to the power 2. Part B. Just expanded. X to the power 3 times x to the power 4. And I'll let you guys do this one. I'll skip down to E. E. So these are a little tricky. We have numbers in front. So here's what I'm going to do. I'm going to write 16 over 2 as a separate fraction. And then I'm going to write times x to the power 4 over x to the power 4 times, and then we have y to the power that looks like 3. And there's no y's on the bottom. So let's see what happens. 16 divided by 2 is 8. And then x to the power 4 divided by x to the power 4. Any number divided by itself is 1. It's a giant 1. And then we have times y to the power 3. 8 times 1, that's just 8, right? So this is 8 times y cubed, or you can just write it as 8y cubed, 8y to the power 3. Okay, uno más. So with these guys, it helps to kind of rearrange. So let's see what's going on here. We have 4 times x times y cubed times 7 times x squared times y to the power 3. Alright, so remember, if there's no exponent, it's to the power 1. So that's x to the power 1. So if we look at this, we've got 4 times 7. So let's write those together. 4 times 7 times, and then we have x to the power 1 times x to the power 2. Then we have y to the power 3 times y to the power 3. We're allowed to rearrange multiplication because multiplication is commutative, right? What that means is 1 times 2 is the same thing as 2 times 1. So you're allowed to like switch the order of the terms and you get the same answer. Alright, so what that tells us is 4 times 7 is 28 times, we've got 2 x's here, and we have just 1 x here, for a total of 3 x's, x to the power 3. Now for the y's, I've got 3 y's, y to the power 3, y times y times y, and I have 3 more y's over here, so for a total of 6. 6 repeated y's, y to the power 6. So our final answer is 28x to the power 3, y to the power 6. 169. Haley and Lacey are rewriting expressions in an equivalent simpler form. Haley simplified x to the power 3 times x to the power 2 and got x to the power 5. Now Lacey simplified x to the power 3 plus x to the power 2 and they got the same result. However, their teacher told them that only one simplification is correct. So who simplified correctly and how do you know? So in class, exponents always go with multiplication, right? So let's check. X to the power 3 times x to the power 2. X to the power 3, that's going to mean x gets repeated 3 times. X times x times x. And we're multiplying that by x to the power 2. X gets repeated twice. Okay? And so what that tells us is we have multiplication straight across and there's 5 x's. So we can simplify that as x to the power 5. Haley is correct. So to see why, let's check out what Lacey did. Lacey did this one. X to the power 3 plus x to the power 2. And the plus sign causes the problem. So x to the power 3, again, is x times x times x plus x to the power 2 is just x times x. So you see how in this one we had multiplication straight across. So we can actually rewrite this as x to the power 5. Well, the problem here is this plus sign does not allow us to write x to the power 5. Alright? So Haley is correct, and how do we know? Well, looking at our problems, Lacey simplified incorrectly. Exponents are for repeated multiplication. Right? Exponents are for repeated multiplication. And Lacey's simplification had a plus sign instead of multiplication. So you can't simplify repeated multiplication with a plus sign, right? So Lacey's simplification had a plus sign instead of a times sign. Something like that. I hope that made sense. Try part B, 171. For a certain function, f of x equals 9, so find the following values. Alright. So what they're telling you is f of x, anywhere you see f of x, it's equal to 9. So for example, f of x, you can erase that and replace it with a 9, right? So this is just equal to 9 plus 3, which is 12. So this is a little bit easier than it seems. B, 2 times f of x, right? A number next to another number you multiply. And because f of x is equal to 9, you just kind of erase the f of x and you replace it with what it's equal to, 2 times 9, which is 18. Alright, equations. I'll do A and I'll do D. For A, combine like terms, but that's finished. So now we go locate the smallest x, which is this one, and we make it cancel. Cancel it by adding x to each side. 3x plus x is 4x, so we're going to have 4x plus 7 equals minus 1, negative 1. Take away 7 from each side, and we get 4x equals negative 1 minus 7. It's getting more negative, is negative 8. Negative 1 subtract 7 is negative 8. And then we divide both sides by 4, and x equals negative 2. D, combine like terms. So we have these two, 3x, now negative 4 add 1. It's getting closer to 0 on the number line. So it goes to negative 3. Then we have negative 2x and 5x. So whatever that is, subtract 5, because that's a minus 5. So 5x minus 2x, that's just 3x, right? Alright, now we need to simplify this further. We locate the smallest x, but each one is the same. So let's make it cancel. Let's subtract 3x on each side. 3x minus 3x cancels. And this is an equation. So we have negative 3 equals negative 5. That's false. That's not true. Negative 3 is not equal to negative 5. So what do we write? There is no solution. How do you tell there's no solution? Well, if both of the x's cancels and you just have numbers left over, you check if it's false. If it's false, it's no solution. So that's what we had. Answer, no solution. Wednesday. Rewrite each expression without negative or zero exponents. Let's start with B. 7 to the power 0. Anything to the power 0 is 1. You just have to memorize that. And if you do, those are always pretty easy. So any exponent of 0, just write 1 as your answer. These ones are a little harder. So when you have a negative exponent, don't forget you cross the line and change the sign of the exponents. Alright, so this is 5 to the power negative 2. I could write it over 1 if I want, right? So because of the negative exponent, this is going to cross the line. 1 over 5 to the power 2. So we cross the line, then change the sign of the exponent. So the exponent, negative 2, we change the sign of that, and now it's just 2. Okay, so that's 1 over 5 times 5, right? Because it's still 5 to the power 2. And 5 to the power 2, or 5 times 5, is just 25. Let's do one more. X to the power negative 2. Put it over 1. Alright, then we have a negative exponent. So what we need to do is have this term cross the line. It's 1 over x. And then we're going to change the sign on the exponent. And that's actually it. That's our answer. Alright, 1-82. I'll let you do A, I'm going to do B. Alright, since we have the output, the rule here is you take the equation, you take the function, the rule and you set it equal to the output, and you have to figure out what value of x, when you square root it, would be equal to 10. Alright, so a couple ways to go about this. Here's method A and method B. You only have to do one, but it might be helpful to look at two different ways to solve this. So first of all, what number, if you take the square root of what number, and you get the output is 10, like what number goes here? It's 100, right? The square root of 100 is 10. So what that tells you is whatever is inside here, we're going to square root it. So whatever's inside here has to be 100, right? So 2x minus 6. We need to figure out what can x be so that this whole expression turns into 100. So 2x minus 6, how can we get this equal to 100? Well, this is just an equation, right? So I can add 6 to each side. And 2x equals 106. And then if I divide both by 2, x equals 53. That's the answer, right? Because 2 times 53 minus 6, all right, if we're checking our work here, take the square root of that. 2 times 53 is 106. And 106 minus 6 is 100, and the square root of 100 is 10, so that actually works. That's a nice way to think about it. Now method B is the more traditional method. So this is kind of an alternate solution. Alright, now when you have the square root in an equation, you can make it cancel by taking the square of each side. If you square each side, square and square root cancel, and you get 2x minus 6 equals 100. 10 squared is 100. And then you add 6 to each side, 2x equals 106, and then you divide both sides by 2, x equals 53. So you have two methods, they both give the same answer, it just depends on which way makes more sense to you. Okay, 183, which ones are functions justify your answer? So let's check this one, doing the vertical line test, and it passes. This is a function. You can say that each input has only one output, right? So this line, we're checking for repeated outputs. So like here, we have one output. There's the output for that input. Output, output. We only have one output each time. Use the vertical line test and use that to finish B and C. Alright, part D. For each graph above, state the domain and range. Okay, so let's look at A. So we have arrows here, and don't forget that the arrows mean infinity. So if you keep going to the right, that's infinity. And if you keep going to the left on the number line, that's negative infinity, because that's the negative side of the number line. So remember, domain is left to right. And from left to right, it's negative infinity to infinity. And the way we write that is all real numbers. If we are covering the entire x-axis or the entire number line, that's just every single number possible, all real numbers. Alright, so that's the answer. Now the range is lowest to highest. So if we check, the lowest value is always here, and the highest value is always there. So the range is all the numbers between here and here. And don't forget, the range is bottom to top. So let's check. Bottom is 1, and the top is 3, right? It just bounces back and forth on the y values between 1 and 3. So from bottom to top, the range goes 1, 2, 3. Now we need to write this with inequalities. So we say that y is less than or equal to 3, but it is greater than or equal to 1. Alright, and I'll do C. Don't forget to do B as well. A little bit quicker this time. Okay, so domain refers to all the input or x values, and you always go left to right. So how far left can we go? Well, here's the leftmost points, -2 on the x-axis, and then all the x values have an outputs. and it goes to infinity. The domain is -2 to infinity. Or another way to think about it is the domain is all the x values that are greater than or equal to -2, right? If this were the number line, you would write x is greater than or equal to -2. Now let's check the range. And the range is bottom to top. So there's an arrow here and an arrow here. So the graph keeps going up and up and up forever. Infinity goes up to infinity. And then this arrow going down means the graph's going to keep going down forever. Now, on this side, this is the negative y-axis, so negative infinity is down here. So on the bottom, we have negative infinity. On the top, we have positive infinity. So which y values can be output? Well, any of them. The whole number line gets covered. So we say all real numbers. Don't forget about B. Okay, 186. The order of operations will be used to simplify the following expressions, that is, PEMDAS. So for this one, I see an exponent. So right away I ignore the subtraction sign. I ignore the multiply sign. I need to do the exponent part first. So what is 3 to the power 2? 9. Okay, so we did the exponent. Next we multiply. So it's 5 minus, what is 2 times 9? Well, 2 times 9 is 18. And then last but not least, we subtract 5 minus 18. It's going to be -13. Alright, now let's go for, let's say, B. Actually, I'll let you do B. D is a good one. So D, we have a negative sign, and we have 2 squared. So don't forget we got to do the exponent part first. It's -2 to the power 2. And 2 to the power 2 is just 2 times 2, which is -4. This one stays negative. That's not a mistake. So -2 squared is -4. Compare that with what you got for B. It's a little different, right? Which I think you have to answer in G. So B and D should be different. Now we go to F. 24 times a fourth divided by -2. But this is not subtraction. This is just saying this number 2 is negative. That's why it's in parentheses. Okay, so we just go from left to right. 24 times 1 over 4. You put the 24 over 1 if you want and multiply across. 24 times 1 is 24 over. And we have 1 times 4, which is just 4. And we're going to divide that by -2. So 24 over 4. 4 goes into 24 6 times, right? This is just 6 divided by -2. And don't forget about this thing. When you have a positive divided by a negative, the outcome is negative. So 6 divided by 2 is 2. I'm sorry, 3. It's 3. Alright, so the answer is -3. Let's see, we have 2 more to go. 1-88. I'm going to use the laws of exponents here. When you divide 2 with the same base, alright, you subtract the exponents. So this is just going to be c raised to the power 8 minus 3, or c raised to the power 5. Let's do D. This one's tricky. So with these, it's helpful to separate everything out. 5 times x times y squared times 12 times x to the power 3 times y to the 4th. So you check for plus signs. There's no plus signs here. And because multiplication is commutative, if you forgot what that means something like 1 times 2. That's the same thing as 2 times 1, right? You can switch the order in which you multiply. So let's switch the order in which we multiply. We have 5 times 12. And then let's put the x's together. Times x to the power 3. And then we have times y squared times y to the power 4. Alright, 5 times 12 is 60. And if something doesn't have an exponent, it's automatically raised to the power 1. So x to the power 1 times x to the power 3, we're going to add those exponents. And then y to the power 2 times y to the power 4. When you multiply two terms with a common base, the exponents add. So it's 60, x to the power 4, y to the power 6. Alright, and C, we have power to a power. People always miss this one. Don't forget that 7 doesn't have an exponent of 4. 7 has an exponent of 1, right? Because if the exponent is not written, it's automatically 1. So this is power to a power. Alright, so when you have power to a power, you're going to multiply. So we have 7 to the power 1 times 2, and then a to the power 4 times 2. So that's 7 to the power 2, a to the power 8. 7 squared is 49. Alright, last one, 191. Calculate f of 4. So there's some tricky ones here. Once you figure them out, I'll do b. F of 4, don't forget the 4 goes in for x. That's the input. So that's the square root of 4 plus 12, and then you divide it by 4. Now 4 plus 12 is 16. So this is really the square root of 16 over 4. And the square root of 16 is just 4. 4 over 4, which is 1. F of 4 equals 1.